Hello, class. Welcome back for part 2 of chapter 8. And if you recall, the first video we dealt with memory and disk. Okay? And then we're going to work on CPU. And then another video, so CPU will be the second video for chapter 8. Third video will be networking, the dump command, and the graphical user interface. All right. So if you remember, we dealt with memory, free uptime, DF, DU, and we're going to move on to this question. I have a question for you regarding CPUs. Can any of you, or you who's watching the video, explain the difference between multitasking and multi-threading? I'll give you a moment, pause the video, think about it, ponder it, consider it, and then hit play to get the answer. Multitasking, if you could look along the bottom here, is I'm running VMware, Word, Firefox, and Zoom, where I'm recording this. All right, if I click on VMware, notice that comes to the front and center of what I'm doing. I click on here, that becomes from the background to the foreground. And if I click here, this is multitasking. I have different apps that are running concurrently. That means at the same time. Not exactly at the same time. All of them are loaded in memory, in Linux or Windows or Mac or your iPhone or your Android are taking times switching between all the apps as see fit. Multi-threading is when I am perhaps watching one of my own videos, for example. All right, such as, let's get rid of that one. I am watching the the sequel or the prequel to this video. I could be letting this play. I hit play. That's streaming right now. There I am. Look, does anyone know why I picked the Earth here? Because I have the Earth in the background here. See, I thought that'd be cool. All right, I matched Linux. All right, so let's get back to our topic of multi-threading versus multitasking. Multi-threading is where you have one program that's playing a video. I could be downloading Fedora, and I could be looking at my emails, right? I could be looking at my emails. I got a lot of emails today. I can be reading my emails while I'm playing my video, and I'm downloading one application, Fedora, not Fedora, Firefox, doing 3 different things on the tab at the same time. That is multi-threading when one program gets multiple processes hung off of that. All right, so that is that explanation. So goodbye to Firefox for now. And let's go look at our checklist. So I am now switching. So we're going to talk about the top. Then we're going to move into the PS. And I'm going to actually reorder these slightly. I'm going to move this to the end. Okay, I'm going to put that there. And we're going to talk about this down here. All right, this is the order we're going to do things. Let's hit the top up. Let's highlight it. That will become our new topic. I will choose green. So top is an automatic refresh of what's going on my machine. So here we go. If you notice right here, here is the memory from this computer, just like the free command. Here is the information that is displayed in the uptime command. See that? Okay, we have 242 tasks running. Okay, 2 running, 240 sleeping, 0 stop, 0 zombies. You'll notice the top is usually in the top consumers of resources because it's refreshing about every 3 seconds or so. If I hit F, I can control what's shown across the top of the top. So I'm going to come here and I'm going to come up here and I'm going to hit the space bar and notice the star goes away. I'm going to down arrow. When I hit the space bar, notice the star goes away there. That means it's no longer included. All right. And if I want the user ID, I come down and hit the space bar. That is now included. I hit Q and you could see the process ID, the user, the priority, and other information is displayed based on what I picked by hitting the F. Pretty cool. All right. Windows has something similar. We'll come back to that. All right. Q gets me out and I can change the refresh rate. I can say top. I want to delay 3 seconds. So every 3 seconds, it's going to go get data or statistics of what's running. I want to do it 5 times. And I want to put the data into a file called top data. Notice it will refresh 5 times at 3-second intervals for a total of 15 seconds. and all the statistical data from the top will be redirected to this file. So we're coming up on about 15 seconds. Let me take a look. Look what I got there, top data. If we take a look at it, there is the data from the snapshots. Pretty cool, right? Each time it refreshed, it did a snapshot and I can monitor what's going on. Now, I'm going to ask you to take a look at this. What do you think this does? Let me go here. I had this problem before and I'm not sure what happened. All right. Okay. I'm going to come to here and I'm going to say delay 3600, number 24. Does anyone want to take a guess what that does? These are seconds. There are 60 seconds in a minute, and there is 60 minutes in an hour. So 60 times 60 is 1 hour in seconds, and I want to refresh 24 times. What this will do is it will gather data every hour for 24 hours. If that is not to my liking, I can come back here and I can say do 1800 -n 48. Anyone want to take a guess what that does? All right, that gives me every half hour a delay 48 times, or every half hour go get statistics on what the machine's doing. More accurate than every hour because jobs can start and stop and pause. So let's see what's going on. What I can also do is say 900 and go 96 times. Every 15 minutes, 4 times an hour for 24 hours, get me what's going on. And I'm going to hit enter. Note it. Oh my goodness, what did I do wrong here? Oh, I know what I did wrong. I need to do -n. All right. Some might say I did it on purpose. All right, here we go. Notice this is running and I'm down to my terminal. I can't do anything more. So if I do a Control Z, I send that to run in the background. All right. Background, it's processing. So I can run something and it goes to the background, or I can launch it, such as gedit, okay, x.txt. And if I put an ampersand, that says run gedit, modifying or creating this file, x.txt, and run it in the background. And you'll see gedit gets launched. If we wait here patiently, there's gedit. And see how it's running independent of my terminal. It's over here. All right, do you remember back in a couple chapters ago, I have a program in SH. I'm going to run. I'm going to go to my home directory, chapter 6 stcc, and I have a script called while sh. I think that's the name of it. No, maybe it's lowercase. Not a directory. All right. So chapter 6. Let's go over to chapter 6. Let's just go to my home directory. I don't know what's going on. I thought I had a directory here. Chapter 6. Let's go see what we can find. Here I am trying to do everything from memory. Chapter 6. I did have a chapter 6 uppercase. I don't know what I did. There I am. And we should have some scripts here. Yes, we have a while. Interesting why that didn't run. While.sh. Do you remember this one? It will allow me to type in a name and it will create a directory. So I'm going to type in my initials, BLC. Okay, create a directory called BLC. And I could do one called Bentley, named after my dog, Bentley Lewis. Now, if I don't want to end the program, I want to pause it. I'm doing Control Z and I move that to the background. All right. So we've learned, let's go to our checklist here. We learned the top command runs in the background. I'm sorry, the top command runs performance information gathering of the top consumers of our CPU. And I'm currently running it in the background. I can use an ampersand to request a job to run in the background. And we also learned we could take an existing job and send it to the background. BG stands for background, by doing a Control Z. All right, now we're going to move into PS, and then we're going to talk about FG in jobs. All right, we're moving right along. Let's come on over to here. All right, so PS shows me my jobs. This is me at the command prompt. Do you remember I ran the top in the background to refresh over 24 hours? I also launched gedit to run in the background. I'm running that shell script, and notice me issuing this command also temporarily creates a process on the system. PID is process ID. This is the terminal I'm working at. This is the time, and this is the command I'm running. I can also do a PS-L for a long list of information. So I get more information here about the process. The difference between a PS and a top is the top constantly refreshes for as long as you tell it to do it, or till you type in Q. The PS temporarily goes out and finds the processes at that exact moment and does not refresh. Also, notice these are my processes only. My command prompt at 73962 is the parent to the top, the gedit, the sh, and PS. My job threaded, multi-threaded these processes. They started it, spawned it, spun it off. All right. So multi-threading is like you're a preschool teacher or a daycare provider or babysitter, and you're watching all the dogs or people or kids in like in a room, and you're making sure they don't hurt each other and they play nicely. That is what multi-threading is in this example. All right. So I'm going to introduce you to the jobs command. And you say, what is jobs? Jobs looks at all my processes, and it says these three are running in the background. Does everyone see that? The top is running in the background. WD is working directory. It's running out of chapter 8, okay? gedit is running out of chapter 8. That's where I launched it from in the SH. So of these processes that are mine, 3 of them are running in the background, all right? I can also do this. I can say find, starting at the top of the file system, any file that ends in py, okay? If you find it, put found. Actually, let me move to chapter 8 directory. Okay, I can say find, that's starting at the top of the file system, looking for any file that ends in py. If you find it, put in py found.txt. Any errors you can put into py error.txt, and I have a decision to make. I can run it right now and hit enter, and my terminal gets tied up and I can't do anything with it. Or I can do the ampersand, say run in the background, and when you finish, you're done. So I'm going to do that. And now notice my jobs has increased by 4 running in the background, and my processes are these. All right. Notice the find is exiting because it finished running in the background. So if I do jobs, I suspect, I hope, that the find is no longer there. It stopped running because it finished. So that means it should have created 2 files, py found, and any errors, py error. Let's see. There they are. So see how the background process ran and it was finished? It stopped running. So we learned that we can tell jobs to run in the background by just simply putting an ampersand. I can also send jobs to the background that are already running by doing a Control C. So let's recap. PS is my commands. My process is running. This is my shell right here. This is my process ID. And these are all my children or sub-processes I created. Of those processes, these 3 are running in the background. Okay, Notice this one stopped because I have echoes writing to the screen, and since I'm not interacting with it, it stopped, okay? The top has stopped because it's sleeping. Every 15 minutes it becomes awake, and the gedit's running, which means if I come over to here, I can type in, see, I can enter in text independent of my command prompt. You may ask, what's this plus? This plus is the most recent one that I was working with before I sent it to the background. If I'd like to bring it to the foreground, move it from the back to the front, I use FG, %, and I use the number that's in square brackets. Python people, square brackets means a list. Same thing here. That's what the square brackets are. So I'm going to say %3. Notice I have to squish it right together. And notice I can create a directory called Sora Candido, and then I could send that to the background with Control Z, and you'll see that that is running in the background. I can bring it back to the foreground by just doing 3, and guess what? It's here now. Bingo. Bingo, I was told today by my son, middle name is his name. Oh, that's what he told me. That's Bingo's full name. All right. And then I could send it to the background. Now I ask you, do you really think these are the only processes that run on the machine? The answer is no, it is not. If I do a PS-E, does anyone know what the E stands for? It stands for everyone. It's going to show me all the processes on my machine. Notice right here, process 1 is the system D. This is the system daemon or service that starts running. Right here is KTHREADD. Anyone know what that is? That is the kernel thread add. It allows the startup to start saying, all right, I'm going to add more jobs. You start the disk, you start the graphical user interface, you start the memory. It does like a delegation. And you could see we got a lot of processes working. We have a lot of stuff going on before I even log in. Take a look at that, and you ask yourself, how many do we actually have? Watch. I'm going to do a PS-E. I'm going to word count how many using good old pipe. I have 248 processes running, and it's only me on the machine, and the rest is Unix just getting it to run. All right, cool. I also want to introduce you to everyone long list full, or the ELF switch. I think an ELF switch cookies, ELF switch. And I'm going to have it go through to the screen, and we get a lot of information. What I really want to show you is the hierarchical relationship. PID, process ID 1, gets up and running. Then the kernel thread add gets started. That's this piece of code that Linus Torvalds wrote that brought together the Linux operating system with all the GNU tools and utilities. Notice the kernel thread add threads or creates all these processes. How do I know that? Because the parent of this process is process 2, started 3, 4, 5, and all the way down the line. Y'all see that? Pretty cool stuff. I want to go over here to Windows. I'm not a big fan of Windows, but I'm going to start up Task Manager. And you will see, if we look at details, look, they have a process ID. And this looks a lot like the PS command, wouldn't you say? And if I right-click this area where the headings are, look, select columns. Look what I get. I get to pick columns across the top, just like I can in the top command. How interesting. All right. We're going to come back and visit this later, but not right now. All right, let's go to our checklist. PS lets me see processes. It's like the top, but it doesn't refresh automatically. It's a one and done thing, and you have to rerun the PS to get more information. The E switch shows me everyone's work. I mean, not everyone's work, everyone's process. F is giving me full information about that process, and L is long list. So if I do ELF, that's awesome. You can also do AUX, which is the Berkeley System Division equivalent of the ELF switch. Just thought I'd tell you that. All right, so I think we're experts here. All right, so I'm going to green there. We learned about how we move jobs to the foreground, or from the background to the foreground using FG, %, and the number. We learned how to determine which one of my jobs are considered background processes. We have to learn about the kill, the PS tree, and the GNOME system monitor. I always want to say GNOME, but no. All right, so let's come over here. Let's take a look. And I'm going to clear my screen. If I do a PS, here's all my processes. If I want to end gedit, see gedit running right here, all right? And I have stuff I typed into it. The kill command kills processes. And if you do a kill-L, which means list, you will see we have 64 different ways to kill a process. In Unix 2, we experiment with more of them, but as a brief overview, 9 ends the job immediately without saving any work. Very dangerous, but a quick way to terminate a process. Other ways of ending is, hey, listen, I'll wait up to 4 minutes, up to 9 minutes. I'll wait nicely for a job to finish, and if it doesn't, then it ends. So what we're going to do is we're going to find the process ID for gedit, which is 74070. See it right here? If I do a kill -9 for process 74070, if you look here, I have a nice text file. I got stuff. Will this be saved? Question mark, question mark. I'm going to come over here and kill the process. Let me move the window in so you can see what happens. Okay, kill. Gone. Doesn't even save the work. It's out of there. All right. So kill allows me to kill processes. I'm going to do clear. I'm going to look at my processes. I'm also going to kill. Remember that shell script we were running in the background? I can do a kill -9, and I can list multiple processes if I want to. I could do 74136. And remember that top that's been lumbering in the background? I can kill that process too by just listing it. So I'm going to ask, what's the command? What's the switch? What's my parameter? If you said kill is the command, -9 is the parameter. Sorry, -9 is the switch. Whew, we can tell we're at the end of the semester. And I have 2 parameters right here. And let's go take a look. Notice those processes are gone. That's the kill command. All right, let's come over to our highlighter here. Kill. PS tree. And GNOME system monitor. We're going to do both of those. So we're going to come back over here. PS tree shows the hierarchical relationship using process ID and parental process ID to show relationships within a process or processes. All right, notice right here, the system D starts up. All of these are launched from the process system D. And then right here, this is the graphical user interface. This starts up, okay, and does this, and then this process starts up and does this, and this process starts up. We can actually see the hierarchical relationship of what processes are related to what processes. Very powerful. If you choose to take Unix 2, which we offer in the fall semester at SCCC, go SCCC, then we delve into this a little deeper. I'm going to get out of here. And what I want to talk about now in our remaining moments on this topic is the GNOME system monitoring. So we're going to do a nice green. I'm going to hit save. I also think we should highlight this because we did some time on that. GNOME system monitoring. These commands are great, right? The free, the uptime, the df, the top, you know, the PS. So the GNOME system monitor brings this all together in a graphical user interface. So I'm going to come over here and I'm going to run it, GNOME-system-monitor. I'm going to run it in the background. I'm going to wait ever so patiently and look what happened. All those commands we've been learning, the DU, the DF, the PS, the top, free, the uptime, is all available to us using the GNOME system monitoring. Did I shut it down? I thought it was hiding out here somewhere. Well, apparently it is not. So let's run it again. There it is. So see right here, we have, did I shut it down again? I think my machine's getting tired. It's the end of the semester. All right, let's see if I have more than one process. Nope, it's not running. It was terminated, just like the Terminator. How about that? How rude, right? All right, let me move this over. Do you know what I think I'm going to do? I think I'm going to end this shell. I'm going to come here. I'm going to start it again. You can also get to the system monitor through the graphical user interface, which I'm going to have another video soon on that. Okay, I'm going to go here. I'm going to go GNOME system monitor. I'm going to run an ampersand. There it is. So notice I see my processes graphically. Here's my CPU history. Here's my memory and swap. You can see I'm using up a lot of the memory and my network history. If I go to processes, notice this looks like the PS command, and it also looks like the Windows. It almost looks interchangeable, right? Look at that. And if I go to file systems, notice I see the information that's displayed in the DF. See the 45%? In my previous video, the DF command show is running at 45%. Pretty cool. So this shows me file systems. This shows me resources. This shows me memory. This shows me resources, CPU, memory, and a network. And this shows me processes. I can sort by process ID. I can do, I guess process ID is not showing. Interesting. Oh no, here's the ID. See right here where it says ID? If I sort on that, there you go. All right. I feel in a very limited time, because I don't want to make these videos too boring and too long, we've conquered all the basics. We came, we took over, we delivered on the process CPU. The next video is going to talk about networking, dumps, and then I'm going to create a video on the graphical user interfaces. All right, stay tuned for the next video. Thanks.